Well, time for paper 2 for times on 1. But before we get started, a couple of things to note that I've noticed from my influx of users. First one, I can't do paper 2. The only reason why I can do paper 1 is because I teach in time zone 1. I teach in time zone 1. So I get a copy of it. So I'm literally taking a picture of the exam, the physical exam, which I have right here. And then I'm doing it. There's no mark scheme yet. Those things come out later, which puts me into my next series of points. I'm doing this blind. At the same time that I am trying to figure out what math I need to do for the question, I am also organizing my thoughts and selecting the way that I want to say my thought process so that it comes out as understandable for you guys. And at the same time that all of that's going on, I am also literally writing out my work, and I'm planning it out, spacing it, and deciding where to write what symbols to use, when to switch colors or use graphs to explain, etc. So balancing those three things out, me trying to figure out what the math, me trying to verbalize my thought process in a way that will make you guys understand, and then organizing my presentation means that all three of those things will not be at 100% because I just can't split my focus that much. So you're going to see small mathematical mistakes. You're going to see like small writing errors. Like maybe I write down an answer for part A, and then for part B, I, for some reason, change the numbers up. Or maybe I say something funny. But yeah, it happens because, I'm doing these things at once. So hopefully you guys can understand. And then before we get started, check out this clown on my YouTube. So this is one of my videos here. And then I titled it GG Easy because from my opinion, I don't think that this is a hard exam for a student. And then this kid with the minion comment, he goes, "Bro, of course it's GG Easy. You're legit quoting from the mark scheme instead of doing it yourself." I mean, I have the mark scheme ready to go because I'm not going to waste time if I maybe get stuck up, but it is easy. I'm a math teacher. None of this is hard for me, unless it's like some really weird, obscure algebraic manipulation that I don't see a point to. But anyways, I thumbed him down because, I don't know, like I'm doing the math. Like there's only so many ways you can do it on a mark scheme, but whatever. So yeah, if you do notice like an arithmetic mistake, please leave a comment, or if I mess something up, please do. But yeah, keep in mind, I'm not putting 100% focus into doing the paper as perfect as I can, just because I literally can't. Anyways, with that being said, I've heard that paper 2 is much more reasonable than paper 1. So I'm gonna just get started here. And okay, what is this? It looks like interest. So Sam invests $1,700 in a savings account and pays a nominal annual interest rate of 2.74, compounded half yearly. Sam makes no further payments to or withdraws from his account. Find out the amount that Sam will have in his account after 10 years. Hey, easy 3 marks. We literally have a formula for that. The future value is the present value times 1 plus the interest rate as a percentage divided by 100 divided by, I don't know what letter is in the formula booklet, but the number of compound interest in a year to the power of KT, where T is in years. So all of this is there for you. So this should be pretty straightforward. 1,700, 1 plus 2.74 over 100. It's half yearly, so I guess that's twice a year. And then this is to the power 2 times 10, which is 20. Okay, and then you put this in a calculator and then you should get your answer. Okay, where's my emulator? Okay, so 1,700 bracket 1 plus 2.74 divided by 200 bracket to the power of 20. Yeah, sure. Okay. So after 10 years, you got $2,231.71. And I know like normally there's 3 sig figs, but of course it's talking about money, and they even tell you 2 decimal places because it's cents. Okay, David also invests $1,700 in a savings account, nominal interest rate of R, compounded yearly, and then he's not going to make any further payments or withdrawals. Find the interest rate he needs so that the amount in David's account after 10 years will be equal to the amount in Sam's account. So now I guess we're going to use part A. And we are going to use different values. We don't know what the interest rate is. It's divided by 100. And this one's compounded yearly, so in this case, K is 1. And this is after 10 years as well. Okay. And then we want to solve this equation. There are a ton of ways to solve this equation. You can use an equation solver. You can graph the right side, find the intersection with a horizontal line at this y value. You can just start to isolate r, which is personally what I would do, just because I'm a fan of algebra. Okay, so we divide this side, and then we're just going to take the 10th root. So let me just write it instead of calculating out this division over here. And so what we can do is we just take the 10th root of this side, and this is going to be 1 point something, and then the something is r, because the 1 comes from here. So I'm going to just take the 10th root of this and then ignore the 1's decimal place, or the 1's place value. 2231.71 divided by 1700. Ah, shoot. Delete. Okay, and then take this to 1/10. And then there you go. So our interest rate is 2.76%. It's only 2% more, huh? Okay. Okay, and then find the interest David will earn over the 10 years. Wait, what? Is the interest he earns not just the difference between the money in his account at the end of 10 years and the money he put in the beginning? It's only 1 mark, so I'm just gonna assume that the interest is how much money he has in his account minus how much he put in the beginning. You know, you kids probably have it more than I do, but like really simple questions give you trust issues. But sure, okay, that's the interest, I guess. And hopefully the music isn't too loud this time. My HL paper 1 was pretty loud. And I guess I can turn up my microphone too, but oh, never mind, it's already maxed out. Whatever. Okay. So we have a frequency table measuring how much time students exercise in a week. The median is 4.5 hours. Find the value of x right here. Okay. So if you have a frequency table, then basically to find the mean, what you're going to do is take each data, which is the number of hours, multiplied by how many students there are, and then you're just adding this up. So 3 times 1 is 3. You know what? Okay. Yeah, no, I'll show my work. I'll show my work. It's only worth 2 marks though, so I don't think you need to show your work if you wanted to save some time here. Okay, and then this is divided by how many there are, which is right here. So that's 5 plus 1 plus 4 plus 3 plus x. So this is my mean. And then this is where I'll probably screw up somewhere with my arithmetic stuff. 15, 5 plus 1 is 6 plus 4, I think this is 13. Okay, and then over here, I know there's a paper too, so I could just type this in, but I don't know. It's like stuff that you should be able to do. 31, 41, 44? Okay. So my... Uh-oh, I totally messed this up. Median. You know, this is the mean, so forget this stuff. Jeez. And I just left a YouTube comment saying the median is not the mean. Okay, the mean is 4.5, which means that it needs to happen right here, in between. So if you notice, there are 10 students here, and then that probably means that you will need 10 students here, so then x is 7. Jesus. Oh well, like I said, doing it blind. Okay, now that we know that this is 7, we can put this into your calculator and then do some table calculations. I have a TI-84. So I'm just going to clear out my lists from previous stuff that I've been doing. Okay, so we got 2, 3, 4, 5, 6. And then 5, 1, 4, 3, 7. Okay, and then we go to stat, calculate, one variable stats. Your data list is list number 1, your frequency list is list number 2. Calculate this. And so my standard deviation is 1.58. And you know what I don't get? People that comment on my errors like right away when they see it. Why don't you, let me finish the question first, just in case I catch it like this one. Because I get the notification and I still see the comment, and then when I go to the channel, I see that it's gone, so they like deleted it. But like I said, feel free to leave a comment on errors if I don't catch them. Okay, I've heard that this one is like terribly easy. So we got a logo, sure. Measures 5 by 4. Points A and B lie on a circle. Oh, right here, A and B. Center, circle, radius 2. Angle, central angle, theta. Sure. Find the area of one of the shaded segments in terms of theta. Okay. So that shaded segment is going to be the area of the sector. Which is 1/2 r squared times theta. And then we are going to subtract the area of the triangle. So this is a fairly standard question. You'll see it a lot in practice exams, exercises from textbooks or whatever. Okay, and then this is 1/2 AB sine theta. Okay. So, in other words, because radius is 2, you're going to have 4 here, and then multiply by the 1/2, you get 2 theta. And then similarly, you're gonna have 2 sine theta over here, because both a and b are 2. Sorry, so here it is. Okay, given that the logo area of the logo is this, find the value of theta. Oh yeah, this is easy. Okay, area of the logo is the area of the rectangle, which is 20, and then you subtract 2 of the area of the shaded segments, which you found out here. So just be careful, you are going to subtract 2 of them. Okay, and then you know that this is going to be 13.4, so you have 20 minus 4 theta minus 4 sine theta equals 13.4. Alright, so this is all GDC, so we can just solve this. For the sake of time, I would solve this graphically, personally speaking, and you know, TI-84, especially on emulator, takes forever, so I'm just going to Desmos this. So my function on the left side, if I treat it as a function, is 20 minus 4 theta, which I'll just write as x, minus 4 sine of x. And then I want to find out when this is equal to 13, so when y is equal to 13.4. And so if I zoom out, I find the intersection, and then the x value is my angle. And obviously make sure you're in radian mode, which I am. So 0.88 is the value of theta. Well, not x, theta. Okay, yeah, that was pretty easy. But maybe I shouldn't say easy because it's triggering some people in the YouTube comments. I don't know. Okay, we got a discrete random variable. Here's the probability distribution. Show that this equation is true. So from the probability table distribution, obviously all the probabilities of your discrete random variable need to sum to 1. And I'm sure if we just collect like terms and move everything to the left side, we will get this equation. Okay, so I guess I'll do that. Ew, I don't want to add decimals together. Okay. So what do we got? We got 0.41. I'm going to collect it with all the other decimals, so minus 0.28, plus 0.46, plus 0.29, so 0.88. So I got 0.88 plus k minus 2k minus squared minus 1. Okay. Oh, and then we're gonna just move everything to the left side. And then you'll get this answer, right? Yeah. This becomes plus, this becomes minus. 1 minus 0.088 is 0.112. Uh-oh. Hold on. This song sounds like copyrightable. Let me just skip that. Okay. Find the value of k, giving the reason for your answer. So we are going to solve this equation. Lots of ways you can do it. Quadratic formula. You can graph it, find the x-intercepts, which is what I'm going to do. So go back to my handy Desmos. So 2x squared minus x plus 0.12. Okay, and then you find your x-intercepts. There should be 2. So you have 0.2 and 0.3. And then you have to give a reason for your answer. So first off, solving this, we have k equals 0.2, and then k equals 0.3. And then you need to make a choice because it doesn't say that there's possible answers. And what you need to do is look at your probabilities. If k is 2.2, no, you can't really see that. Then look at the probability for when the random variable is 1. It's going to be a negative number. So you can't have this one. It has to be 0.3. And then you can probably check this one as well, but it can't be this one. So your only choice is this one. Hence, find EX. Okay, so now that we have our k value, we can actually find the probability that goes in each table. So let me just rewrite this again. 0.41. What's 0.3 minus 0.028? 0.02, 0.046. And then instead of plugging in 0.3, because I don't want to square this and do that, I know again it needs to be 1. So let's see, 41, 87, 89. So this is 0.11, I think. Okay, and then to find the expected value, we are multiplying each thing together and then adding them up. So zeros don't matter. I got 0.02. I got 0.92 plus 0.33. Okay, and then this goes over 1, so I don't want to think about it. 0.02 plus 0.92 plus 0.33. 127? Sure. So far, not that bad. Like honestly, like these are very typical questions. Okay, we have a particle, we have its velocity. Find the value of t when the particle is at rest. So if it's at rest, then obviously it's not moving. So this is when v is 0. Okay. So easy enough to do. We are basically finding the v-intercepts. And so we can just go to our graphing display calculator, type in our function. So e to the sine t, or sorry, x plus 4 sine x okay. And then you have all of this stuff. Now, of course, this is between 0 to 6, so you can change your window to 0 to 6. I can, on Desmos, literally restrict my domain to 0 to 6. And as you can see, there's only one value where it is at rest, which is right here, 3.35. So GDC, x-intercept. I'm not sure if I accidentally said v-intercept, but yeah, x-intercept. 3.35. Okay. Find the acceleration of the particle when it changes direction. So when it changes direction means that its velocity is well, it's right here when the velocity is 0. So when you are moving, before you change direction, like for a split second, you need to stop because then you're going to go back. So we're relying on our answer from part A. When it changes direction, again, is when velocity is 0, and given our graph, there's only one place where it is 0, which is right here. And then we want the acceleration, which is the derivative of velocity. So we need to find the derivative of the velocity at our value from part A. And I'm pretty sure Desmos can do this too. I'll call this like f of x. Then what is f prime at, what is it, 3.34? So as you can see, the velocity is negative 4.71. And I guess technically this should be 3.35. Okay, and then we need to find the total distance traveled by the particle. So if you want to find total distance, there's two ways that you can do it, because the integral, so let me just demonstrate this. Integral from 0 to 3.35 of f of x dx. Okay, it doesn't show you, but our function has an area above the x-axis and then below the x-axis, and so you technically are moving at some distance, for example, to the right, and then you move some distance to the left. And so if you were to just straight up integrate from 0 to 6, you won't get total distance. You're going to get total displacement, which is how far away you are from the beginning. So what you can do is you split this integral up into two parts, from first 0 to here, the 3.35, and then 3.35 to 6. Or normally what I would recommend is you take the integral from 0 to 6, but you do the integral of the absolute value of your function. And this is all something you can just plug in into your GDC and it'll just spit it out for you. So like I said, integral 0 to 6, and then this is the absolute value of my function dx. So here, let me just show you the difference without the absolute values. Okay, so because you're moving, for example, to the right and then you move to the left, you end up, let's say for example, 7.8 meters to the right of where you're starting. However, that is not your total distance. You've actually moved a total of 20. It's just because you move to the right and then to the left, you don't see that total 20 in your displacement. But anyways, so this is what, 20.8. And then don't forget your units, whatever they are. Seconds, meters, whatever. Yeah, okay. Standard questions. Okay, next up. Let A and B be two independent events such that A intersection B complement is this. A complement intersection B is that. Given the intersection of A and B is x, find the value of x. Okay, well, I always like to do a Venn diagram to help visualize stuff. Okay, and then you need to know what section of the Venn diagram this is, A intersection not B. So this is the section of the Venn diagram that is part of A, and at the same time it is not part of B. So that's this part right here. So this is 0.16. They tell you the intersection is going to be x, and then same reasoning, this is going to be right here. Okay, then we need to find the value of x. Okay, what have I not used in the question? Oh yeah, okay. They're independent events. So what that means is that in your formula booklet, you can look this up too. Independent events have A intersection B be equal to the probability of A times the probability of B. So we know that this is X, and then the probability of A, a lot of students get confused, but this is the entire A. So that is both of them. So the probability of A is 0.16 plus X, and then for similar reasons, 0.36 plus X for the total probability of B. Okay, and then again, many ways to solve this. So pick your poison equation solver. It's a quadratic formula. After you collect everything to one side, you can find the intersection of two graphs. You can move this term over and find the x-intercept of a single graph, whatever. I'm gonna find out the intersection of two graphs, y equals x, and then y equals this stuff. Why? I don't know, because I can. Just making sure I copied down what I wrote. And then as you can see, we have one intersection right there, 0.24. And then find, well, probability of A complement given that is not, or given that is B complement. You can use the formula, etc., etc. But first, let me just throw this in here, that this is 0.24. Okay. And use the formula, go ahead. But let me do this in a different way. So a given means that you already know that this is part of your outcome. So, and I'm technically using the formula, but I'm giving it kind of context. So you know what the outcome is. The outcome means that it has to be a B. So it's out of, so your denominator is out of a total of 0.24 plus 0.36, which is, I think, 0.6. And then out of these probabilities, which one is not A complement? It has to be 0.36. So it's 0.36 out of 0.6. And if you didn't get what I said, just use the formula. So 0.36 divided by 0.6. So this is 0.6. Okay, this one was a little odd. I would say that this is probably the hardest question so far. Yeah. And then from there, I think we move on to part B. This one. I also heard that this one was super easy. Okay, we got a pyramid, and then they tell you some coordinates. Point V has the coordinates 1, 5, 0. Point A has the coordinates -1, 1, and 6. And then you can't assume that this is a square base. Oh yeah, never mind. It's right here. Read the question. Okay, square base. So then that means that these are the same lengths. Okay, and then hence find AV. So they want you to find this length right here. And there's a straight up distance formula in topic 3. So AV is going to be the square root of 1 plus 1 squared plus 5 minus 1 squared plus 0 minus 6 squared. Yeah, you just subtract all your components, square them, add them together, square root them. Okay, so this is 4, this is 16, this is 36. So square root of 56 is AV. Okay, given that angle A to V to B is 40, find angle or find side AB. Okay, so what we're going to do is we need to now find out this length right here. And then you're basically given this angle AVB. So just redraw your triangle in flat. And then you want to find this, I don't know, call it X. You know that this is root 56. By symmetry, this one is also root 56. This is V to B. And they just told you that this thing is 40 degrees. Okay, so given this setup, we have side in between, or an side angle side is what I say. And so we can use cosine law. Just make sure that your calculator is in degree mode. And then we can find out X. It's a straight up plug and chug type of example. So, did you know that Google has a cosine law calculator? Okay, so I want to solve for the side. So this side is, oh, I don't know if it can do square root 56. Damn it. Do I want to do this the long way? Whatever, fine, we're going to do this the long way. It's not even that long because both the sides are square root 56. Okay, x squared is equal to 56 squared, which is 56, plus the other 56 squared, square root 56 squared, which is 56. And then this is subtract 2 times the square root of 56 times the other square root of 56, which is 2 times 56, which is 112, cosine 40 degrees. Okay, which means that x is going to be the square root of all of this stuff. Blah. Okay. Okay, make sure I'm in degree mode. Quit. And then, okay, I got 56 plus 56, which is 112. And then I'm gonna minus 112 times cosine 40. And then I'm gonna take this to the square root. 5.12. So 8, this is 5.12. Okay, then the height, or sorry, the volume of the pyramid is this. Correct to 3 significant figures. Find the height of the pyramid, Vx. Okay. So again, in your topic 3, or maybe, yeah, I'm pretty sure it's in topic 3, there is the formula for the volume of a pyramid. It's a 1/3, and then I don't know how vague it is, but it's the area of the base times the height. And we know that this is a square base pyramid, and we just found out the length of the side of the pyramid. Whoa, I completely wrote that wrong. .12. Okay, so this is just going to be on the left side. We know it's 57.2 from the question. So 1/3 area of the base. It's 5.12 times itself because it's a square. And then you want to solve for h, right? Okay, easy enough to do. So 57.2 times 3 divided by 5.12 squared. So the height of your pyramid is 6.54. And then, oh, this is about an ornament that goes on like a Christmas tree. A second ornament is in the shape of a cuboid, rectangular base. X, 2x, width of x, height of y. Cuboid has the same volume as a pyramid. Cuboid has a minimum surface area S. Calculate S. Okay. So this one. So one of these dimensions is x, the other one's 2x, and then the other one is y. The volume is the same as the pyramid, so this has the same volume, 57.2. So 57.2 is equal to the volume, which is the area of all of the faces of your thing. So for example, this little right face that has an area of x times y. This upper area right here has an area of 2x squared. And then this front facing one is 2xy. So you can add these all up and then times them by 2 because there's 2 of each face. Like this one's the top one, so there's one on the bottom. This one is in the front, there's one in the back, etc. So I guess we just do that. So 2 of 2x squared plus xy plus 2xy. Okay. And then, oops. Hold on. Okay, so times 2, this is 3xy. When you collect them together, times it by 2 is 6xy. Okay, and then if you have the ability to graph a relation, you can just type this in. For example, well, I can just type it straight into decimals. But, you know, if you have an older TI like this one, you'll have to isolate for y, which isn't that bad either. Yeah, so moving this term over to the left side and then dividing by 6x, you'll have this. And then wait, I totally messed this up. Shit. Okay, I'll add a timestamp for this. Okay, this is the surface area. I knew this was oddly suspicious. Okay, this is S. And then we want to minimize this. And then we know that the volume is base times width times height. And then what we're going to do is we're going to do substitution so that we do not have two variables, independent variables. I'll add timestamp. It is what it is. Okay, so 57.1 divided by 2x squared is equal to y. Okay, so like I said, this is going to be 2x plus 3y, xy. So 4x squared plus 6xy, which is equal to 4x squared plus 6x. And then we're going to make our substitution. Okay, and then we just GDC this and find the minimum. It happens. It's only been 45 minutes. If I was writing the actual exam, got lots of time. So my y is going to be the surface area, and you got 4x squared plus 6x times 57.1 divided by 2x squared. And then you'd probably adjust your windows. And then there is your minimum. So x is going to be 2.78. And what does the question want? Find the find the value of s. So I don't even need this one. I need the y coordinate. 92.5. Silly me. Oh well. Okay, we got rational function. Write down the equation of the vertical asymptote. It's literally right there. It's where you would divide by 0. So vertical asymptote is at x equals 4. Horizontal asymptote is the coefficients of x, the ratio of the coefficients of x. So your horizontal asymptote is 4/1, which is 4. Okay, then we are going to find the inverse. So it's a pretty typical inverse question. You can set the whole function equal to y, and then we go through the algebraic process. So you switch x and y. This is usually worth 1 mark. And then basically we multiply this over to the other side. So you'll get x times y plus 4 is equal to 4y plus 1. And we're going to multiply in the x with the ultimate goal of collecting all of our terms with y in it on one side so that we can factor it out. So here, it doesn't really matter which way you go. I'll make this one go this way, and then I'll make that one go that way. So you got xy minus 4y is equal to 1 minus 4x. And then we can get a single value of y by factoring it out. Therefore, your inverse would be this function. Okay. And then using an algebraic approach, show that the graph of f is obtained by a reflection of the graph of f in the y-axis, followed by a reflection in the x-axis. So what they're saying is that you need to show that f inverse is a reflection in the y-axis and then a reflection in the x-axis. In other words, this is equal to negative f of negative x. So that's where the two negatives would go. This one's for the reflection in the x-axis. This is the reflection in the y-axis. Okay, so where's my original function? It's right here. Man, we're just chilling. Okay, so first off, negative f of negative x. This is going to be negative, and then f is this of negative x. So what do we got? We got negative 4x plus 1 over negative x plus 4. And then if we just keep manipulating this and stuff, we'll get to what we want, which is this thing. Okay, so notice that I do have the numerator already. It's just kind of in the wrong order. So we're good. And then that basically means that this negative is going to be multiplying into the denominator because I have the exact opposite signs that I need for my inverse. So this is equal to 1 minus 4x if I rearrange the terms on the top. If I multiply the negative in to the denominator, I'll get positive x minus 4. And then this is the inverse. Okay. Okay, next up. The graphs intersect at 2 points. P is the x value that's less than the other one. Find the value of P and Q. So we can just graph both because we have both functions and find their intersections. So you can use your GDC. I'll use decimals. Shoot, what are my functions again? Okay, 4x plus 1 over x plus 4. And then my inverse, one minus 4x divided by x minus 4. And then as you can see, I have my two intercepts. And there's lots of ways that you can do this, by the way. So this is just like the surefire way to do it, that you could do it with any two functions. But, you know, if you're smart, the only way for an inverse and the graph to intersect would be they would intersect along the x equals y line. Whoa, that is a really good line. So yeah, because of like the way the symmetry works, the only places that they do intersect are along this line. Although I guess it doesn't really help you know that it's going to be at 1 and negative 1. But it does mean that you do know that the y and x values have to be the same thing. Sure, whatever. Ignore what I said. That's just a little tidbit, I guess. Not that it matters to you guys because you're done. But okay, GDC, right? Intersection. Hence, find the area enclosed by the graph of f and f inverse. Now, this is actually taken from a different question. Oh, I shouldn't have erased that line. That was so good. Wow, that one's also pretty good. Okay, so my black line is f, okay? And then let me throw this in here too, y equals x. And then we want the area enclosed, so we're only looking at this area right here. That's between both graphs. So this is between 1 and 1, negative 1 and 1. Okay, so we're just trying to find this area here. So because of the way it's symmetric about the XY axis, we realistically only need to find 1/2 of the area and then we double it. So we know that this is at negative 1, and then this goes to here somewhere to 1, and then this is f, right? So if we want to find this area, we're just going to take the integral from negative 1 to 1 of the function minus the other function, which is this line here. So minus x dx. And then we're just going to multiply this by 2 so that we get the full area. Okay, easy to do. So you can just do that all in your GDC, find an integral of a function. So I'm going to do the integral from negative 1 to 1. I'm going to multiply it by 2, and my integral is f of x minus x. Okay, and then there you go. That should be your answer, 0.675. So yeah, like I said, find the area between the function f and the axis of symmetry, y equals x. So the area between them means you subtract the two functions. From negative 1 to 1, double it for the other side. Yeah. Okay, and then we're on the last question. And this looks like our probability, standard deviation, standard distribution, probably binomial distribution question. They love doing this one. And I'm under an hour, pretty good. Okay, bakery makes 2 types of muffins, chocolate and banana. They should consider making one that does both. In one, weights, c grams, chocolate, normally, mean, standard, probability, weighs less than 61. Damn, they're just giving you some free marks right here. So we're just doing the probability that your muffin, I guess chocolate muffins are X. I'll just say for the future's sake, banana muffins are Y. Less than 61, right? Okay, well you have the mean and you have the standard deviation, so we can just throw this right in a calculator. So normal CDF. We don't really have a lower boundary, so we just put some obscenely small number. We have an upper boundary. What's my mean? 62. Standard deviation 2.9. So 0.365. Okay, in a random selection of 12 chocolate muffins, find the probability that exactly 5 weigh less than 61. So you see, we switched to a binomial distribution now. Where you have 12 trials, they're chocolate muffins, and then they're either less than 61 or more than 61, which is exactly a binomial theorem, or binomial distribution, sorry. So we're just gonna go to distribute binomial PDF. There's 12 trials. The probability of a trial being less than 61 grams is what we got from part A, so 0.365. And we are interested in having exactly 5 of these muffins be under that weight. So paste it, press enter, 0.214. Nice. Okay, now the weights of the bananas. Oh, I guess, they already changed the variables for this, so C for chocolate. So B, bananas, grams, has its own distribution. Oh, I honestly thought that they wouldn't have told us one of these and then you'd have to standardize it. Oh well. Okay, each day 60% of the muffins made are chocolate. So let's just write down that that means that 40% are bananas. On a particular day, a muffin is randomly selected from those made at the bakery. Find the probability that the randomly selected muffin weighs less than 61 grams. Okay, so for this, you're going to have to, I would recommend you make a tree, right? You got chocolate, and then you got banana. And banana was what, 40%? Chocolate was 60%? Because the probability of it being under 61 grams will depend on which cupcake or muffin it is, because they're going to have different probabilities for being under that weight. So C being more than 61, actually let's do less than 61 on the top. So C being more than 61, so, and then this one, bananas being less than 61, bananas being more than 61. Okay, so we are, oh yeah, and then write down the probabilities. So 0.365. Let me color code this a little better. Probability will be red. This one is going to be 0. Don't want to do that mental math. So we're going to subtract that from 1 to find the complement. Okay. And then if we want to find out the probability that it weighs less than 61 and is chocolate, we would multiply these two probabilities together. So 60% times 0.365. So 0.219. And then I'm not super interested in this one for now. And then I need to find out the probability that a banana is going to be less than 61. So I'm going to norm CDF this with a different mean and standard deviation. So the banana muffin is 68 mean and standard deviation of 3.4. Okay, so this one has a different, whoa, why is this so different? Did I mess up the first one? Hold on, let me just double check my numbers. Oops, not that one. Sure, whatever. Okay, 0.198. Okay, so probability of being less than 61 and it's a banana is going to be these two multiplied together. .00729, I think it was. Oops, other way around. Okay, so then now we can answer this. Find the probability that a randomly selected muffin weighs less than 61. So these are both the ways that you can be less than 61, so we add them together. So this is the probability that your muffin weighs less than 61. So plus 0.219. So 226.0227. Okay, and then just a little note. I am rounding as I go, and you technically shouldn't be doing that. You should only be rounding to 3 significant figures at the very end. So all of these are going to be off by a little bit, but it's not off by that much. It's not enough that I care for it. I mean, obviously you guys should, because I don't know who your marker is going to be. Okay, and then given that a randomly selected muffin weighs less than 61 grams, find the probability that it is chocolate. So this is conditional, because pretty obvious. So find the probability that it's chocolate given that the muffin is less than 61. So again, you can follow the formula. We're going to divide by the probability of it being less than 61, which is exactly the answer we have from the previous part. And then we would need to find their intersection. So this is the probability that your chocolate intersection, your muffin is less than 61, which is why we made the tree, because that probability is this one right here. This is the probability that you're chocolate and you're less than 61. Okay, punch it in a calculator and then you are done that question, except for one more part, but you're done this part of the question. 96.5%, which would be this decimal. Okay, and then this is the final question. Lots of time to spare. We got a machine. It makes chocolate muffins, adjusted so that the mean weight of the chocolate muffins remains the same, but their standard deviation is going to change. Okay. I think I've seen this question before. So the machine that makes the banana muffins is not adjusted, so that one stays the same. The probability that the weight of a randomly selected machines is now 0.157. Find the value of sigma. Okay. So this probability has changed. Sorry, let me scroll up. So this probability has changed. However, it's saying that the banana machine has not been changed. So this is still the same. So first off, let me just write that all out. So now that it's been adjusted, it is 157. Okay. All right. The muffin machine has not changed, so I'm going to subtract this from it because that would mean I have a new probability for the chocolate machine. So then I'm going to take, so this means that the probability that your chocolate and your muffin is less than 61 is going to be the total probability of being less than 61 minus the probability of the banana one being less than 61. Okay. I have a feeling I've messed up a number somewhere on the way here. .149. Okay. And then what are we supposed to do? The chocolate machine makes the whatevers. Find the probability that the weight. Okay, first off, we are going to now, well, we're going to do the standardization because we need to find standard deviation. Now, first off, you will also note that to do that, we are going to eventually standardize. Well, sorry. Let me change colors. Okay, whatever. So our goal is to standardize the probability of a chocolate muffin being less than 61. And we will eventually find this probability. However, that is not this probability, the 0.417. What this is if you remember the tree diagram, it's the first off the probability of the muffin being chocolate multiplied by the probability of the chocolate muffin being less than 61. So what I need to do is I need to take this new probability of their intersection, and then just keep in mind that this is the probability of it being a chocolate muffin. And none of my variables are fully correct because this is here. Let me just write chocolate. This is just me being pedantic, but you can't use C for two different things. And this is the probability of chocolate being less than 61. Okay, but this still remains the same probability. They didn't say that that changed. So I am going to take this one and then divide it by 0.6 so that I can get this one. So divide this one by 0.6, this number, and then I get 248, I guess. You should use all your decimals, but whatever. Okay, and then we are going to standardize this because we don't know the standard deviation, so we standardize it so that we can use the inverse function. So this becomes probability of Z is less than 61 minus the mean of a chocolatey thing, which is the same as before. Mean weight stays the same, so 62. But you don't know your new standard deviation, but the probability remains the same. Okay, so 61 minus 2 is basically -1 over sigma. And then on the other side, we are going to inverse norm this to get the actual numerical value of the z-score. So second distribution inverse norm, whatever area this is, 0.248, and then this is why you standardize, because you can't use inverse norm unless you know mean and standard deviation, and the mean and standard deviation of any standardized one is 0 and 1. Okay, so my z-score is negative 0.681. And then of course this just means that theta is going to be whatever it needs to be solving this equation. I think it's 1.47. Yeah. And then that's it, we're done. With about 15 minutes to spare. Okay, much easier. This was a little tough one, this last question. Not the entire thing, just this last 5-mark one. And then, I guess if you haven't seen this question before, it might have been a little difficult. And this one might have been difficult, I accidentally messed it up. This one was a little difficult, and then the rest were, I think, fairly standard, if not relatively straightforward questions. Yeah, overall, much better than Time Zone's paper 1. Okay, if you're an SL student, congratulations. I hope that you finished your math. Some of you, this might be the last time you ever do math again. If you're an HL, well, stay tuned for the HL video and also the paper 3 video. Okay, thanks for watching. See you guys later.